Okay, guys, 7.6, we're talking about inverse of a square matrix. So let's talk about what the word inverse means. It means opposite. And square, we're going to be dealing with just the square 2x2s. So just with our inverse notation, when we found the inverses of our equations, we're going to use inverse notation with matrices. So whatever the letter is that the matrix is called, like if it was matrix A, the inverse notation would be A with a little -1 up here in the corner. So we need to make sure that we have our inverse notation. When you find the when you find the inverse, it's the second thing we're going to do today. The first thing I'm going to do right now is just to verify that two things are inverses. And in order to do that, you will multiply the two inverses together both ways, A times B and B times A. When you multiply them like that, and the identity matrix is revealed, when you multiply A times B and you get this as an answer, and when you multiply B times A and you get this as an answer, that is proving that two matrices are inverses of each other. So in that case, if we were going to multiply here and show that B is the inverse of A, we're going to multiply A times B, and we're going to multiply B times A, because in order for them to be inverses of each other, both things have to be true. So I'm going to write out my A and my B. So A is -1, -1, 2, and 1. And B is 1, 1, -2, -1. So when we multiply, this is a 2x2 and a 2x2. So my answer is going to be a 2x2. So let's talk about this. This circle right here. It's going to be row 1 times column 1. So -1 times 1 is -1, and 2 times 1 is 2. So -1 plus 2 is 1. So now I'm going to find this answer here. So it's going to be row 2 times column 1. -1 times 1 is -1. 1 times 1 is 1. So -1 plus 1 gives me 0. So now I'm going to find this right here. So it's going to be row 1 times column 2. So -1 times -2 is 2. 2 times -1 is -2. So 2 minus 2 is 0. And then I'm going to find this value right here, which is second row, second column. So -1 times -2 is 2. 1 times -1 is -1. 2 minus 1 is 1. So if you notice here, when we multiplied A times B, the inverse matrix was the product. So now we're going to do the exact same thing, but now we're going to put B first. So B, 1, 1, -2, -1 times A. And again, we can multiply these together because the inside dimensions are the same. The outside dimensions give us what our answer is. So my A matrix is -1, -1, 2, and 1. So if you multiply A times B and the inverse matrix presents itself, and then you do it backwards and the inverse matrix presents itself, then you have proven that the matrices are inverses of each other. So again, I'm going to find this value right here. First row, first column. 1 times -1 is -1. -2 times -1 is +2. So -1 and 2 is 1. I'm going to find this column down here. So that's second row, first column. So 1 times -1, -1. -1 times -1 is +1. -1 plus 1 is 0. Find this value here. It's first row, second column. So 1 times 2 is 2. -2 times 1 is -2. So -2 and +2 gives me 0. And then this column here would be, that part of the column would be second row, second column. So 1 times 2 is 2. -1 times 1, -1. 2 minus 1 is 1. So again, guys, the inverse matrix was the product. So you have now proven that B, as the question says, B is the inverse. How did you do that? Because when you multiplied A times B and then B times A, the identity matrix was the product. All right, so now if you are given a 2x2, and we're only going to talk about 2x2 matrices in order to find the inverse. To find the inverse, this is what we do. And I wrote these steps over here for you. Steps to find the 2x2 inverse. The first thing you're going to do is find the determinant. Of the given matrix that they give you, you find the determinant. That's your major, A times D, minus your minor, B times C. Then, in order to do this, you have a little formula here. You're going to use this formula. First of all, here's our inverse notation. So we need to use that. Inverse notation. And then we have this little fraction out here in front. If you notice, this fraction is 1 over whatever the determinant is. The determinant. So you're going to set that up, determinant. And then the next thing you're going to do is you're going to say, okay, well, with the matrix that I was given, I'm going to switch the places of the values on the major axis. And I'm going to negate, which means change the sign on the stuff on the minor axis. So if it was positive, it's going to become negative or vice versa. Then we distribute and write our inverse notation. So let's go through this so you guys can see it. It says find the inverse. So the first thing I want to do is find my determinant. I'm going to multiply my major, which is 1 times negative 3, minus my minor, which is negative 1 times 4. So I have negative 3 minus a negative 4. Well, negative 3 plus 4 gives me the whole number 1. So as I set up my inverse notation here, I have negative 1. I have 1 over my determinant. Well, my determinant value is 1. And then I have to write this matrix. So I switch the places of the major. So negative 3 moves up here and 1 moves down here. Then I change the signs of the minor. They stay in the same spot, I just change the sign. So negative 1 becomes positive, positive 4 becomes negative. And then I distribute. So I'm just going to multiply everything by 1, which it's going to stay the same. So the inverse is negative 3, 1, negative 4, 1. So sometimes your inverses look similar to their originals, and sometimes they don't. Sometimes you'll be asked to determine, and if you have a multiple choice question, sometimes it's really easy for you guys to just go, oh, okay, I'm just going to pick this one because it looks like it's the opposite and this and that. I wouldn't do that. I would actually go through the math so you can see. Sometimes it's real easy to pick out and sometimes it's not. All right, so moving on to these next two examples, guys, we're going to do the same thing. We are going to find the inverse, and if you notice here in the example, it says find the inverse if possible. So maybe that means sometimes it's not possible to do. So step number 1, find the determinant. So I'm going to take 3 times 2 minus negative 2 times negative 1. So 3 times 2 is 6, minus negative 2 times negative 1 is 2. So my determinant value is 4. So let's get our little formula set up. I have my inverse notation of 1 over my determinant, which is 4. And now to find the inverse, we switch the places of the major. So 3 and 2 are going to switch spots. 2 goes there, 3 goes there. And then you're going to negate. You're going to change the signs here. So this becomes positive 2 and positive 1. And now we take 1/4 and we're going to distribute. So I have the inverse of A is negative 2 times 1/4 is going to give me negative 2 over 4, so negative 1/2. 1/4 times 1 is going to give me 1/4. 1/4 times 2 is going to give me positive 1/2. And 1/4 times 3 is going to give me 3 over 4. So this one, the inverse didn't look like the exact opposite like the first one did. So sometimes, like I said, sometimes they're going to look different. Sometimes they're going to look the same. Now, how could you check this? You could multiply A times your inverse and your inverse times A. And if both times you multiply, you get that of 1, 0, 0, 1. When you multiply this and this, then you've proven that you could check, I guess you could say that your answers are right. So let's look at the next one. All right, find the inverse if possible. Well, first step, guys, find your determinant. So 3 times 2. 3 times 2 minus negative 6 times negative 1. So 3 times 2 is 6, minus negative 6 and negative 1 is 6. So here my determinant value is 0. So let's get our problem set up. Inverse of b would be b to the negative 1. And did I forget the negative over here? I did. There should be a negative there, and there, and there. Okay, so then I take my 1 over my determinant value, which is 0. And then think about it. When we get this set up, we're going to switch the places of the majors. So 2 and 3 switch spots. Then you negate the minors. You change their signs. So 6 and 1. Now, some of you are saying, wait a second. Guys, what happens here when your determinant value is 0? If you have any fraction with 0 as a denominator, this becomes undefined. So what is that telling you about the inverse of matrix B? It means there is no inverse. So when you are going to this, and say you take this first step and you're like, okay, let me find the determinant that I'm going to put under the 1, and I get a 0 here, you can stop right there and say no inverse. And the reason why is because this value is 0, and when you put it underneath the 1, it becomes undefined. So that is a possibility that you could have no inverse. So if you guys have any questions, make sure you're coming to class and talking to me. Remember, all of these homeworks are due on Monday, so don't get behind. Get ahead and get them done.